to area equals to 1/2 integration from A to B r squared d theta. Okay, so this is the formula to calculate area in polar coordinate. So basically, guys, subtopic 4.1 is about single integration. Okay, single integration in polar. Single integral. Okay, so as usual, let's take a look at the exercises. So exercise 4.1. Okay, exercise 4.1. Let us do question number 1. Find the area of the region enclosed by the rose curve r equals to 4 cos 3 theta. Question number 1. Okay, so how many petals do we have here for this question? R equals to 4 cos 3 theta. 3 theta, okay, good. So basically, guys, in order to answer or calculate area of the region, we need to sketch the region, of course. Okay, so let's sketch the rose curve. This is what I mentioned in our previous class, that we know in final exam we will cover only chapter 3 and chapter 4. However, what we already learned in chapter 1, okay, as for example, we already learned how to sketch the graph of rose curve in chapter 1, isn't it? So we are going to use this, the lesson in chapter 1 again in chapter 4 indirectly. Okay, so we have X and Y. So rose curve, we have 3 petals. Cos, so we have first petal, second, and third. Okay, so in this question, it does not mention number of petals. So we assume that we are going to calculate whole petals. Okay, so 3 petals. So first of all, what you should do is you have to find the angle. Okay, find the angle. So the angle is actually the limit for the integration. Okay, as we notice here, we have limit of angle theta is from A to B. So this is the angle or the limits of the integration. Okay, so let's say I want to consider the first petal, this first petal. So we need to find the angle bounded by this petal. Okay, so we need to find what's the angle here and what's the angle here. All right, and then we know that the length of petal is 4. Okay, so in order to find the angle for rose curve, this method is specific for roses only. Okay, for rose curve. Okay, how do we find the angle? Is by letting r equals to 0. Okay, in order to find the angle, we let r equals to 0. So we will have 4 cos 3 theta because r is 4 cos 3 theta. So equate this with 0. So we will have cos 3 theta equals to 0, of course. So 3 theta equals to r cos 0. So what should you get? R cos 0. Shift cos 0. If you use your calculator, then you will get what?
90.
Pi over 2.
90 degrees or pi over 2, yes. Okay, so therefore theta should be 90 divided by 3. We have 30 degrees, or we can say that pi over 2 divided by 3, we have pi over 6. Okay, so now of course, right here, we will have theta equals to pi over 6. And what happened at the lower angle? It should be negative pi over 6. Okay, pi over 6 and then negative pi over 6. So now we will have, okay, let us calculate the area equals to, we have 3 petals, isn't it? 3 petals. So we have we have put 3 multiplied by, the formula is 1 over 2. Okay, 1 over 2 and then integration from negative pi over 6 until pi over 6, we have 4 cos 3 theta squared d theta. All right. So this is the first method. Okay. We consider from negative pi over 6 until pi over 6. Or you also can consider half of the petal. Okay, guys, you can consider half of the petal. If you have something like this, let's say I just consider first half here, half of the petal. So I will consider angle start from 0. Okay, so we will have another formula is area equals to 3 times 1 over 2 times 2, because I consider angle from 0 until pi over 6. And then the R is the same. So 4 cos 3 theta squared d theta. Okay, so if you're comfortable with this formula, then you can use this. But for me, I prefer the second one because we have angle equals to 0. It's much easier to calculate angle equals to 0. Okay, both will give you the same answer, so you don't have to worry. Okay, so let us proceed. This equals to, this one can be cancelled, of course. So we will have 3 integration from 0 until pi over 6. So 4 squared is 16. Cos squared 3 theta d theta. So 16 times 3, we have 48. Integration from 0 until pi over 6, we have cos squared 3 theta d theta. Okay, guys, we have a double angle formula. Okay, as we know, if we have cos squared theta, then this is equivalent to 1 over 2, 1 plus cos 2 theta. Okay, therefore, in this case, our angle is 3. Okay, our angle is 3 theta. So cos squared 3 theta is equivalent to 1 over 2, 1 plus cos 2 times 3 is 6 theta. Okay, so we have to substitute cos squared 3 theta with this one. Therefore, we will have equals to 48, 0 until pi over 6, cos squared 3 theta equals to 1 over 2, 1 plus cos 6 theta d theta. So now 48 times half equals to 24. And then 0 until pi over 6. Why 24? Because multiply by half. Okay? So integrate 1, we get, we just copy dulu, step by step. Yes, as your friend mentioned earlier, integrate 1, we will get theta. Okay, this is 1. Integrate 1, we get theta. Integrate cos, we will get?
Positive sign.
Okay, positive sign. Where should we bring this?
Over 6.
Yes, over 6. Yes. So we have plus sine 6 theta over 6. So substitute over 6 and 0. So pi over 6 plus sine 6 times pi over 6. So we will have pi over 6. And then minus 0. So 0 plus 0. Okay. So as we know, sine pi is 0. So pi over 6 times 24, we will have 4 pi. Okay, so that's the answer, 4 pi. Okay, next question. Find the area of the cardioid R equals to 1 minus cos theta in the second and fourth quadrants. So guys, actually this question is you have to calculate it separately. Because if you look at the answer, we have two answers, right? So in the second quadrant, of course, we know that from this is the first quadrant, second, third, and fourth. Okay? So you have to identify the angle accordingly. Okay? So I think question 2 is quite easy. All right, so we proceed to question number 3. Find the area of the region inside the cardioid and outside the circle. So question number 3. Okay, so 2 plus 2 cos theta, and then we have a circle radius 3. So let us sketch the region first. Okay, we have radius r equals to 2 plus 2 cos theta, cardioid. This graph should be symmetric to which axis, x or y?
X.
X axis, okay, because we have cos. All right, and then we have plus. Plus means right or left?
Right.
Right, okay, good. So we have this. Okay, we will have this. Oh, before that, let us sketch the circle first. Okay, circle should be easy, just very simple. We have this circle. We have 3 and 3, right? Now let us sketch the cardioid. So cardioid should be on the right. So we will have something looks like this. Okay, and here is 4. All right. So now it said that you have to find the region inside the cardioid and outside the circle. So of course, the region should be here. Okay. So what you have to do now is we need to find the intersecting angle between these two lines. So the intersecting angles is here and also here. Okay, so we need to find the angle right here and right here. So what you should do now, find the intersecting angle. Okay guys, in order to find the intersecting angle, you have to let R1 equals to R2. So the first R should be the cardioid. 2 plus 2 cos theta equals to second R is 3. Okay. So we will have this. So let us solve this one. 3 minus 2 is 1. So cos theta should be 1 over 2. So theta is shift cos half. What should you get? What's the
Pi over
angle?
3.
Pi over 3 or 60 degrees, right? So theta equals to pi over 3. So, of course, here we will have pi over 3. Since the graph is symmetric about x-axis, of course, we have here, down here, negative pi over 3. So right now, let us calculate the area of the region. A equals to 1 over 2 integration from negative pi over 3 until pi over 3. Okay, guys, so which one? Circle minus cardioid or cardioid minus circle?
Cardioid minus circle.
Okay, yes, that's correct. Cardioid minus circle. So cardioid is 2 plus 2 cos theta. Don't forget you have to put squared because the formula is r squared. Minus circle. Circle is 3, so 3 squared d theta. Okay. Or, okay guys, again, or alternatively, we can calculate the area by considering half. Okay, let's say I consider this part half. So my angle will be starting from 0, isn't it? So we will have 1 over 2 times 2. Why I multiply by 2? Because I consider angle start from 0 until pi over 3. Okay, and the function inside here should be the same. Okay, so cardioid minus circle. So we will have 2 plus 2 cos theta minus 3 squared d theta. Okay, so now let us proceed. I can cancel this easily. So let us expand this one. Okay, guys, slowly. So 2 squared, we will get
4.
4. Okay, and then 2 times 2 times 2 cos theta. Multiply
8 cos
everything.
theta.
Yeah, so we have 8 cos theta. After that, we plus 2
4
cos
cos
theta.
theta.
Yeah, so we have 4 cos squared theta. Okay, good. And then minus what? Minus 3 squared. So we
9.
will have 9. Yes. So let us solve this. We will have 0 until pi over 3. All right, so 4 minus 5, we will have negative 5. Plus 8 cos theta plus 4 cos squared theta d theta. All right, so now cos squared theta is equivalent to 1 over 2, 1 plus cos 2 theta. Okay, so we have to substitute this inside the function. Then we will get negative 5, 4 times half, 1 plus cos 2 theta d theta. Okay, so from here we can get 0 until pi over 3 negative 5 plus 8 cos theta plus 2 cos 2 theta d theta. Okay, so negative 5 plus 2 here, we will get negative 3 plus 8 cos theta plus 2 cos 2 theta d theta. Okay, now we can integrate. All right, integrate negative 3. We will get negative 3 theta. Integrate cos. We will get sine theta. How about this?
Cos sine to theta.
Yeah, sine to theta. Where should we bring the coefficient to here?
Over.
Over becomes denominator. Okay, so 2 sine 2 theta over 2, like this. So substitute 0 and pi over 3. Okay, guys, now we can cancel this. All right. So we will have negative 3 times pi over 3 plus 8 sine pi over 3 plus sine 2 pi over 3 minus, okay, 0 plus 0 plus 0 lah, of course. So if you use your calculator, sine pi over 3 is square root 3 over 2. Sine 2 pi over 3 also square root 3 over 2. So guys, we will have negative 3. Okay, so we get negative pi plus 8.
3.
Yes, square root 3 over 2 plus square root 3 over 2, like this. So therefore, we have negative pi plus 9 square root 3 over 2. Right, so that's the answer. Okay, so next question. Which one? Okay, question number 4. Find the area enclosed by the circles. This also the question. You have to answer it separately. This is not the combination. So r equals to 2. Of course, we just have radius 2. R equals to negative 3. Also a circle with radius 3. And then r equals to 4 sine theta. Okay, guys, let's say we calculate for r equals to 4 sine theta. Question number 4a. Okay, let's say r equals to 4 sine theta. All right. Because for this case, for r equals to 2, the angle is from 1 over 2, 0 until 2 pi, so 2 squared d theta, isn't it? And then for r equals to negative 3, it's just 1 over 2, integrate from 0 until 2 pi, negative 3 squared d theta. All right, so now we focus on the third question, r equals to 4 sine theta. Okay, so r equals to 4 sine theta. This graph should be located in which axis? On which axis?
Why?
Y. Okay, so we have x and y, so we have this. All right, so what's the value here, the coordinate? 4. Okay, so the radius, of course lah, radius pula. Shaded region dia, of course macam ni lah. Okay guys, can you give me the bounded angle? The angle. I want to calculate the area now. 1 over 2. The angle start from? Just look at the figure. Just look at the region.
2 pi?
Oh, the
Theta from 0 until theta equals to?
Pi over 2.
Not pi over 2. Pi over 2 atas.
Hi.
Yes. Very good. So we consider angle start from 0 until pi. Okay, because the graph is located up above y-axis only for the first quadrant and second quadrant. So that's why we consider from 0 until pi. Okay, so the r squared. So r is 4 sine theta squared d theta. So let us proceed. 1 over 2, 0 until pi, we have 16 sine squared theta d theta. Okay guys, if, yes saya,
Boleh buat half kan?
boleh, yes, of course you can, from 0 until pi over 2. Yes, can, and then you have to multiply by 2. Okay, that's good question. Also, you can consider a half, so you will have, macam ni 1 over 2 times 2 from 0 until pi over 2 lah. So 4 sine theta squared d theta, like that. Okay, just the same. All right, so let us proceed. Okay, now we have sine squared. Just now cos squared equals to 1 plus cos 2 theta. 1 over 2, 1 plus cos 2 theta. So for sine squared, the double angle formula is 1 over 2, 1 what?
Minus.
Minus, yes, very good. Minus cos 2 theta. Okay. So we will have half times 16, so it should be 8. 0 until pi, so 1 over 2 lagi. 1 minus cos 2 theta d theta. So 8 times half, of course we have 4. 0 until pi, 1 minus cos 2 theta d theta. So integrate 1, we get theta. Integrate negative cos, we will get?
Negative sine to theta over 2.
Yes, very good. Negative sine 2 theta over 2. So you just need to substitute pi and 0. So we will have here pi minus sine 2 pi over 2 minus theta equals to 0. Sine 0 also 0. So of course sine 2 squared is 0. So we will get, the answer is 4 pi. Okay, so this is the answer.
Doktor,
Yes.
nak tanya kalau contoh untuk soalan ni kan dia ada tulis yang pertama sekali dia suruh cari area untuk R equal to 2 and then
Yes.
this one the radius also equal to 2, then can we say that since both of the circle has the same radius, then the value is equal, then no need to calculate this one, just let it equal to the 4 pi.
Then no need for you to learn single integration. you can double check. Okay, guys, listen here. You can double check. Let's say in final exam, you nak double check betul tak you kira. You can double check by using the formula of pi r squared. Okay. So sorry, please can you mute? Okay, can you mute? Guys, boleh tak mute dulu? Sekejap I will explain. Okay. Like one of your friend asked just now, it's a very good question. Okay, the formula is pi r squared, isn't it? Formula is pi r squared. So as we know that the graph is like this just now, like this equals to 4. This is a complete circle. So we know that the radius here is 2. R equals to 2. So if you calculate the area of this circle, of course we get pi multiplied by 2 squared. So we have 4 pi. You can use this to double check your answer in final exam, just to double check. But you cannot use this formula to show the answer because we do have marks for the steps. Okay, understand what I mean? Guys, you have to show. Okay, you have to show the steps of integration here. Alright? You nak guna formula boleh, hanya untuk double check jawapan sahaja. Itu pun kalau kebetulan soalan macam ni lah, memang direct lah. Okay, but in your final exam, it's not direct lah, of course. Okay, it must be combination, something like that. Understand?
Okay, Doktor, understand.
Okay, good. Okay, good. So, okay, the rest of question B, C, D is very simple because we have specific region, third quadrant, second quadrant. Okay, so I think let us proceed to question number 5, combination. We go to combination part because I believe in final exam, your question will be a combination of 2 types of graph. Okay. So let us do question number 5. Question 5. Okay, so let us sketch the graph of this question. We have again a circle and cardioid. However, in this case, I believe that the coefficients are the same. We have 2 here. We also have 2 and 2. So, okay, let's say I start with circle. Okay, guys, 2 minus 2 cos theta, which exists? X or Y?
X pada sebelah
X,
kiri.
right or left? Should be on the left because we have negative. Okay, so your graph would be here, the cardioid. Okay. Now, guys, this graph, we will have same point. The intersection point is located exactly on the axis. Betul-betul berada pada paksi. Okay, kalau tadi, just now, for question number 3, the intersection point, this intersection, is not located on the axis. So we need to find the intersecting angle. Okay, ni kita kena cari intersecting angle by equating both of the arm. However, in question number 5, the intersecting angle is located exactly on the axis. So we can just directly identify the angle by just looking at the graph. So no need for you to calculate. You tengok graph pun, you dah boleh tahu dah angle di kat mana, berapa nilai dia. Okay. So let's say we will answer question number 1. So question number 1 said we have region outside the cardioid. Outside the cardioid, but inside the circle. Okay, outside the cardioid, inside the circle. Outside cardioid, inside circle. In the first quadrant, lagi satu, ada lagi. In the first quadrant. Kenapa dia lari pula ni sekejap Okay, let me highlight this again. Outside the cardioid, inside the circle, in the first quadrant. So the region should be here, isn't it?
Yes.
Okay, so now we know that this angle here is 0 until this point, angle equals to pi over 2, 90 degrees. Okay, so straight away calculate the area of the region. 1 over 2 multiplied by integration from 0 until pi over 2. Okay, right now circle minus cardioid or cardioid minus circle?
Circle minus cardioid.
Yes, very good. Circle minus cardioid. Well done. Because this line, okay, what happened guys? This line dari sini minus this line. Okay, so circle minus cardioid. Alright, so let us proceed. Circle is 2 squared. So minus cardioid is 2 minus 2 cos theta squared d theta. Alright, so now let us expand this one. 4 minus. Okay, open the bracket. We have 4 minus 2 times 2 times 2. So becomes 8 cos theta. Negative 2 squared. So we have positive 4 cos squared theta d theta. So of course we can cancel this 4 minus 4 becomes 0. And then we have negative become positive. So 1 over 2. Alright, so again, don't forget you have this term. So cos squared is 1 over 2. Okay.
Negative.
Huh? Negative, yes. Thank you for correcting me. Yes, we have negative. Negative, positive, and then negative. Yes. Okay, that's correct. Negative, positive. So becomes negative. Okay, so let us proceed again. Okay, so we will have minus 2 cos 2 theta d theta. So let us integrate 8 cos theta becomes 8 sin theta minus 2 theta minus 2 sine 2 theta over 2, substitute pi over 2 and 0. Of course, we can cancel this. So we will have 1 over 2, 8 sine pi over 2 minus 2 times pi over 2 minus sine pi. Of course, when we substitute everything with 0, becomes 0 lah. Minus 0, macam tu. Okay, so we will have here is 1. This can be cancelled. Sine pi is 0. 1 over 2. 8 minus pi. So we have 4 minus pi over 2. Okay, this is the answer. Alright, so next question. Can you understand this, guys? Alright, so next question, question B. Sketch and find the area of the region outside the circle. Okay, outside the circle but inside the cardioid. Outside circle, inside cardioid. Jom kita lukis sekali. Question B. we have a circle, and then we have a cardioid. Okay, oops. 2. All right, so X and Y. Okay, let's say we have the blue color. Apa ke soalan tadi? Outside circle, inside cardioid. Outside circle, outside
Bentuk
circle,
bulan.
inside cardioid. Ah, bentuk bulan, pandai awak. Bentuk bulan. So now guys, the angle, of course, the angle above here is pi over 2. How about the angle here?
3 pi over 2.
Yes, okay, 3 pi over 2, very good. So let us proceed with the integration. Area equals to 1 over 2 multiplied by integration. Okay, the lower limit should be smaller. Okay, so it should be pi over 2 until 3 pi over 2. Okay, right now, circle minus cardioid or cardioid minus circle?
Cardioid minus circle.
Cardioid minus circle.
Okay, good. Cardioid minus circle. So we will have 2 minus 2 cos theta squared minus 2 squared d theta.
Kata yang ni boleh half lagi kan? As long as symmetry.
Boleh. Boleh. Kalau nak half suka hati, boleh. Doesn't matter. Sebab dia symmetry. Yes, good. So 3 pi over 2. Let us proceed. 4 minus 8 cos theta minus become plus 4 cos squared theta minus 4 d theta. So now again, we can cancel this. And then this one, it becomes 1 over 2, 1 plus cos 2 theta. So we will get 1 over 2, pi over 2 until 3 pi over 2. So we have negative 8 cos theta plus 4 times half. So 2 plus 2 cos 2 theta d theta. Okay, so we will get this. Integrate negative 8 cos theta, so negative 8 sine theta plus 2 theta plus 2 sine 2 theta over 2. Substitute 3 pi over 2 and pi over 2. So we will have negative 8 sine 3 pi over 2. This one can be cancelled. So 2 times 3 pi, sine 3 pi lah. Minus. Okay, I will copy here. Negative 8 sine pi over 2 plus 2 times pi over 2 plus sine 2 times pi over 2 is sine pi. Alright, so here is sine 3 pi over 2 is negative 1. And then this can be cancelled. This is 0. Sine pi over 2 is positive 1. Sine pi also 0. So we will have 8 plus 3 pi and then minus negative 8 plus pi, isn't it? Okay, so we will have 1 over 2, 8 plus 8, so 16 plus 3 pi minus pi, 2 pi. So we have 8 plus pi. Okay, so that's the answer. All right.
Doctor,
Yes.
can I ask if, let's say, I want to do the half one, right? So let's integrate from pi to pi over 2, is it?
If you want to consider half, you will have like this area equals to, so you consider until pi, isn't it? So you will have 1 over 2 times 2 from pi over 2 until pi. like that.
Oh, so I'll get the same answer, right?
Yes, you will get the same answer. And inside function inside here should be the same. 2 minus 2 cos theta squared minus 2 squared d theta. You will get the same answer. Right? Don't worry.
The sign is also the same, right?
The sign, you mean the sign, the position, cardioid minus circle should be the same. Yes, should be the same.
Yeah, I mean the final answer outcome.
Final answer should be the same.
Oh, okay.
Okay,
Okay.
welcome. So let's take a look at question C. So question C inside both, okay, inside both circle and cardioid. Inside both circle and cardioid. In the third quadrant. Okay, inside both circle and cardioid in the third quadrant. So let us do question C. Oh, sorry. Question 5C. Inside both circles and cardioid. So we have a circle and this is the cardioid. Here is 2. Here is -4. Okay. Inside both circle and cardioid in the third quadrant. So we know already that here is the third quadrant. So inside both, guys. So where is the shaded region? Where should I shade the region?
Quadrant.
Betul, the quadrant. Inside both means here, isn't it? Inside both. Kalau if you consider this, ni di luar circle, outside circle. So inside both means only this region. Understand?
Understand.
Okay,
Yes.
so now can you give me the angle? What's the angle
Pi
involved
under
here?
theta over 2.
Yes, here is theta equals to pi and right here is theta equals to 3 pi over 2 lah. So dia bermula daripada titik sini sampai sini kan. This region. Okay. So we will have area equals to 1 over 2 integration from pi until 3 pi over 2. Okay, what is the r now? What is the r involved here?
Cardioid minus circle.
Perlu ke cardioid minus circle?
Tak. Circle je, circle.
Circle je kan? Betul tak? Ni, I will highlight with the green color. This line, you consider this line. Okay, garisan ni, this line is belongs to the circle, isn't it? So we just consider circle. So our circle is 3, 3 pula, 2. So 2 squared d theta. Okay, because we are not involved any cardioid here. Alright, so we just consider the line equals to 2. So we have 1 over 2, 4 theta lah jadinya. 4 theta, substitute pi and 3 pi over 2. So 4 pi times half is 2 pi, 2 pi, 2 theta, substitute 3 pi over 2 and pi. 2 times minus 2 pi. So we will have 3 pi minus 2 pi is pi. Okay, so that's the answer. Alright, so we finished already subtopic 4.1. Let us proceed to 4.2. Double integrals over rectangular region. Alright. Okay, so basically double integrals over rectangular region. We will have something looks like this. integration of region R, we have fxy and then dA. Okay, dA can be either, this dA can be either dy dx or dx dy. In rectangular region, you can simply change the position, the order of the integration. Okay, you can just simply change the order of integration because in rectangular region means the other meaning of rectangular region means all the limits are constants. So more limit to constants. So we can just simply change dy dx into dx dy. Okay, only for rectangular region. But for the next subtopic 4.3 in non-rectangular region, you cannot just simply the order of integration. Ikut ada satu step tertentu lah. Okay, so let us discuss on exercise 4.2. Exercise 4.2. Okay. So I will start with the easiest one, question number 1. Exercise 4.2. Question number 1. Okay, so in this question, we also need to sketch the region and evaluate the integral. So we have to sketch the region and evaluate the integral. So in order to sketch the region, let us take out the limit. Okay, guys, listen here carefully. So the inner part is y. Of course, the limit should be 0 until 3. So we have y starting from 0 until 3. And then the outer limit is belong to x. So we have limit of x from 0 until 1. So x is from 0 until 1. So if I sketch the region, okay guys, region R, of course we have x and y. So y from 0 until 3, and then x from 0 until 1. So we have this. Okay, so this is the rectangular region. Kenapa rectangular? Because all the limits are constant. Okay, so let's proceed with the calculation. Equals to 0 until 1. Okay, now guys, when you want to integrate with respect to y, okay, x becomes constant. All right, x becomes constant. This x is a constant. You should assume that x becomes a number, a constant. The same concept applied in previous chapter, chapter 3, when we want to differentiate partially. Okay, the same concept here. All right, so we integrate 2x. It becomes 2xy. Okay, because x is just a constant. So integrate with respect to y, we get 2xy. Plus integrate 1 with respect to y, of course we get y. Substitute the limit y equals to 0 and y equals to 3 dx. Okay, so we will have 0 until 1, 2x times 3 minus, plus 3 minus, substitute y equals to 0, so 0 plus 0 dx. So we will have integration from 0 until 1, 6x plus 3 dx. Okay, so integrate 6x, we will integrate 6x, we will get 3x squared plus 3x. So substitute 1 and 0. So we have 3 plus 3 equals to 6. Understand, guys?
Faham.
Okay, so let's move to the next question. Okay, let's say we do question number 4.
Tapi doktor,
Yes?
kalau ikut yang apa tu, panjang darab lebar tu dapat 3 kan?
Apa dia?
rumus nak cari luas rectangle dia.
Rumus nak cari luas rectangle.
Betul, satu darab
Sebabnya
tiga.
itu macam ni guys, macam ni, you jangan confuse. Nak cari luas itu betul lah area. Area tanpa function. Dalam kes kita, kita ada function. Itu membezakannya. Kalau you kira area semata-mata, memang dia dapat 3. Sebab area sahaja. Faham tak? Yang ni dia ada function. So bila ada function, dia affect lah kita punya nilai. Understand? Okay, so let us proceed. Question number 4. Kita buat ni lah. Okay. So now X is from, again, inner, mesti inner limit. Dia macam tu. So inner X starting from 0 until pi over 2. And then Y is from pi over 2 until pi. Pi is also a constant, dia bukan function. Pi also a constant number. So let us sketch the region X and Y. Okay. We will have, oh guys, before that, if you want to calculate jadi 3, macam mana nak dapat 3 tadi tu? Kawan you kata, betul lah. 3 darab 1 jadi 3 kan? Okay, nak dapatkan ni macam mana? Kalau guna integration, you kena buat macam ni. 0 until 1, 0 until 3, dy dx. You akan dapat 3 without function. Tak ada function. Ni sama dengan 1 ni, dia tak ada function. Kalau dia ada function, dia takkan jadi 3 lah. Understand?
Faham.
Okay. So now, we have from 0 until pi over 2. X from 0 until pi over 2. Let's say here is pi over 2. And then Y from pi over 2. Let's say pi over 2 here. And then until pi. So here. So we have this. And this. Okay, so the region should be this. This is your region R. Okay. So let us proceed with the calculation. Integrate cos. We will get what?
Sine.
Sine. Okay, so 2 sine 2x over 2. Okay, now what happened to this? 3 sine 3y ni guys. We want to integrate with respect to x. So what happened?
Negative 3y.
Okay.
Ada.
You could negative 3y. This is just a constant, right? Constants. Because dia adalah y. So kita nak integrate terhadap x. So what happened?
0.
Tak zero. Integrate guys. Integrate. You
Tambah
kena
X.
assume. Tambah x. Yes. You kena anggap 3 sin 3y tu equivalent to number 10. Okay. For example, kalau you confuse je, kalau you confuse je, you terus buat macam ni. Okay. Integrate 3 terhadap x. Okay. 3 is constant. Okay. Jap. Integrate, let's say 10 terhadap x. So integrate constant, you akan dapat 10x. Macam tu. So you kena anggap ni constant. Macam nombor 10 juga. So 10 darab dengan x. So darab dengan x lah. 3 sin 3y darab dengan x. So it becomes minus 3x sin 3y. So we have x here. Didarab dengan x lah sebab dia integrate. So substitute the limit x equals to 0, x equals to pi over 2. Understand guys?
Faham.
Doctor, is it a must to write the x equals to 0 and x equals to pi over 2?
No, I just do this so that students can understand and not confused when you substitute.
So in exam, if you do write the x, you just straight away pi over 2 is okay, right?
It's up to you. Okay, I'm doing this so that you know you have to substitute the values of x here and the values of x here. So you have to be careful with this sign y. Don't ever substitute into y.
Okay, thank you, Doctor.
Understand?
Yes.
Okay.
Thank you.
That's why I do that, so that student don't get confused. So now you have to substitute into the x. So this can be cancelled. We will have sine 0 minus 3, sine 0 pula. Sine 2 times pi over 2. Yes, so sine pi minus 3. Tengok substitute dekat x ni. Jangan substitute dekat y, substitute dekat x. So 3 pi over 2 sine 3y. Minus, substitute 0, so sine 0 is 0. 3 times 0 also 0. dy. Okay, so if you calculate using your calculator, then you can get 0 here. So finally, you will get integration from pi over 2 until pi, negative 3 pi over 2 sine 3y dy. So of course, you can take out negative 3 pi over 2 because it's just a constant, isn't it? So integrate sine, we will get integrate sine.
Positive cos. Negative cos.
Negative cos, right? So negative cos 3y over 3. So substitute pi over 2 and pi. So of course, in this case, we can cancel this 3. Negative, negative also becomes positive. So we will have pi over 2 cos 3 pi minus cos 3 pi over 2, like this. So of course, cos 3 pi over 2 is 0, cos 3 pi is negative 1. So pi over 2 multiplied by negative 1, we can get negative pi over 2. Okay, so that's the answer. Understand, guys?
Area boleh negatif
Ini bukan area. Sebab dia ada function. Yes, kalau area dia takkan ada function kat tengah. Okay? Sebab dia ada function, guys. So it's something else. Dia bukan area lah. Please. Question number 5. So now let us proceed. Again, guys, ln 3 and ln 2 is just a constant. So you have y from 0 until ln 3, and then x from 0 until ln 2. So if you sketch the region R, so we have here ln 0 until ln 3. Ln 3 is just a number, ln 2 kat sini. So you akan dapat rectangular region lah. This is your region R. Okay, so let us proceed with the calculation now. 0 until ln 2, 0 until ln 3, exponent to x plus y, dy dx. Okay, so now since we have exponential to the power of summation, so 0 until ln 2, we can take out exponent to x. Okay, I can factor out this exponent to x and then integrate exponent. It becomes like this lah, macam tu. Okay, so 0 ln 3. Saya asingkan jadi macam ni. Dy dx. Understand the steps? Saya tak integrate lagi, saya just separate this. I just separate the power of exponential. Dia akan jadi exponent 2x darab exponent y, macam tu kan? Okay. So we will have ln 2. Exponent to x is just a constant because we want to integrate with respect to y. So exponent y integrate dapat exponent y juga lah, dia tak ada beza. Okay, so substitute y equals to 0, y equals to ln 3. So dx. So we will have from 0 until ln 2 exponent to x. So substitute exponent ln 3 minus exponent 0 dx.
3 minus small 1.
Yes, so this is equivalent to 3 and this is equivalent to 1. So 3 minus 1 becomes 2 lah, dx. Okay, 3 tolak 1 jadi 2 lah kan? Integrate exponent to x. So 2, 0 until ln 2 exponent to x dx. Macam gini lah. Okay, so integrate exponent to x, you will get exponent to x over 2, isn't it? So substitute 0 and ln 2 inside the x. Of course, we can cancel this. So we will have exponent ln 2 minus exponent 0. So we will have
4.
2
2 darab ln 2.
2 ln 2. 2 ln 2 macam gitu.
So 2 pindah atas jadi 4. 4
Yeah,
minus
so ln 2 squared minus 1, isn't it? So we have
4
4.
minus
Yes, 4 minus 1, we get 3. So the answer is 3. Okay. Understand, guys?
1.
Okay, next question. Let's say question number 6 is similar to question number 7. So let's do question number 7. All right. So now, okay, I just proceed with the calculation, okay? So equals to pi over 2 until pi. Okay, now we want to integrate with respect to y. Okay, so x becomes the constant. I should highlight the constant as green color. Okay, so what happened, guys? Integrate x cos xy with respect to y.
By part.
By part. Kenapa kena guna by part? Guys, okay, guys. As I mentioned earlier, these x are just constants because we want to differentiate with respect to y, kan? So you kena anggap macam 3 cos 3y integrate terhadap y. Kena guna by part ke? Tak payah kan? Tak apa, that's good, it's okay. Saya dah cukup happy you respond dalam kelas online ni. So salah pun tak apa, don't worry guys. So kalau you integrate ni awan nano ni, saya letak dalam awan nano ni. So kalau you integrate 3 cos 3y ni dapat apa?
3 sin 3y per 3.
Yes, 3 sin 3y over 3, isn't it? So the same thing happen here. Okay, saya tukar je tadi tu. X tu jadi nombor 3. So dalam kes ni, if we integrate, we will have x sin xy over x. Right? Because x is the constants. So substitute ni, that's why saya letak supaya you tak confuse nanti. So y, substitute y equals to 1, y equals to 2. So dx. Okay, so right now you can cancel this. Alright, so we just substitute y, pi over 2 until pi, sin, okay, substitute dekat y tau, so sin x darab 2, so jadi sin 2x, minus y equals to 1, so sin x dx. So we just need to integrate this, integrate sin dapat apa?
Negative cos.
Yes, negative cos 2x over 2 and then minus negative cos x like this. Okay, substitute pi over 2 and pi. So we will have negative cos 2 pi divides by 2 minus become plus cos pi minus negative cos 2 times pi over 2 divides by 2 minus jadi plus cos pi over 2. So if you use your calculator, cos 2 pi is 1, cos pi is negative 1, Ni cancel jadi cos pi should be -1. Cos pi over 2 is 0. So jom kita akan dapat negatif 1 minus 1 minus negatif times negatif. Jadi positif 1 plus 0.
Negatif over 2.
Over 2. Yes, thank you. Kat sini pun over 2 lah kan? Okay, over 2. So negatif 3 over 2 minus 1 over 2. Negatif 42, so negatif 2. Alright, so we will have negatif 2. Understand, guys?
Understand?
Yes.
Okay, so next question. Which question?
10.
Question number 10. Alright, so let us do question number 10. Okay, so integrate this. Since the question does not mention either dy dx or ds dy, so it's up to you. You can use either one, dy dx or ds dy. So right now, you nak suruh saya buat apa ni, dy dx or ds dy?
dy dx.
Nak dy dx boleh, jom kita buat. Xy over square root of x squared plus y squared plus 3 dy dx Okay, so dy dx. So y, limit of y should be the inner limit. So from 0 until 2. So we have 0 until 2 and then limit of x from 0 until 1. Okay, from 0 until 1. So let us proceed. Okay, so we are now integrating with respect to y. So what are the constants?
X.
X the constants. Okay, so x the constant. Okay, guys, so we will have, we need to make a substitution. Okay, we let u equals to x squared plus y squared plus 3. Okay, so now we differentiate u with respect to y. We will have 2y dy. Okay, we will have 2y dy. You can anggap right now you have to bear in mind x squared also a constant. Dia sama taraf macam nombor 3 tu Okay, so what happen next is let us change the limit. Saya nak tukar limit terus.
Masukkan dekat dy.
Okay, so du, okay. Before that, du equals to dy equals to du over 2y lah. Okay, and then right now I want to change the limit. When y equals to 2, so u equals to x squared plus 4 lah kan, 2 squared. Ni, saya gantikan dekat sini ni. Ni, y equals to 2 ni. So jadi x squared plus 2 squared plus 3. So u becomes x squared plus 4 plus 3 is 7, isn't it? And then when y equals to 0, we will have u equals to x squared plus 0 plus 3. So therefore u equals to x squared plus 3. Okay, so yang ni saya padam dulu. Therefore equals to
Range baru.
range baru. Ya, betul. Sebab saya nak buat substitution terus. So right now guys, we have to change this and this. Okay, you have to change. So 0 dia jadi, kalau 0 dia jadi x squared plus 3. And then kalau yang atas ni dia jadi 2 tu dia jadi x squared plus 7. Okay. And then x ni maintain. xy maintain over square root u. Okay, kenapa square root u? Sebab ni adalah u punya u tadi. Okay, so over square root u. Okay, now dy ni adalah equivalent to du over 2y. Okay, so I put here du over 2y. And then dx just maintain lah. Okay, now we can cancel this y and y. Okay, so we will have 1 over 2 can be taken out. So x over 2 can be taken out. All right, x over 2, x squared plus 3, x squared plus 7. X over 2 can be taken out because it's just a constant. And then u ni jadi negative 1 over 2. Saya nak buat naik atas. So du dx. So now we can integrate u lah. Okay, we just integrate u here. U to the power of negative half with respect to u. So bila you integrate, you all akan dapat 0 until 1. X over 2 can be taken out because it's just a constant. Integrate u to the power of half. So negative half plus 1 becomes half, isn't it? Yeah.
Over
So
half.
1 over 2, yes. So substitute lah. U equals to x squared plus 7. U equals to x squared plus 3 dx. Okay. So now 0 until 1, x over 2. Half ni, over half ni, it becomes 2. Okay, multiply by 2. Alright, so u is square root of x squared plus 7 minus 2x squared plus 3. Okay, so dx. Alright, so now we can cancel this 2 ni. So what happened, guys? You will have 0 until 1. X square root of x squared plus 7 minus x squared plus 3 dx. Ni saya darab masuk sebab dia kurungan kan. This one, x ni you darab here and then you darab also here. That's why dia ada x dekat luar tu lah. Okay guys, what happened next? You have to make this as two integration. Let's say this is part A and this is part B. So let us solve one by one. Solve A.
Substitute.
Yes, good. Substitute lagi sekali. We let u equals to x squared plus 7. Yes, so differentiate u, we get 2x dx. So dx becomes du over 2x. Okay, and then when x equals to 1, what happened to the u? U equals to 1 squared plus 7. Ni, gantikan dekat sini. Okay, so when x equals to 1, of course 1 squared plus 7 becomes 8. And then when x equals to, apa tu, 0. 0, dia jadi u equals to 0 squared plus 7, so it becomes 7. Okay, so now kita solve satu-satu ya. Kita solve part A dulu. So part A. Integration, substitute 0 and 1 ni with this 7 and 8. So we will have 7 here, 8 here. Okay, and then x maintain, x. And then square root. X squared plus 7 is actually your u. Okay, so square root u. Du, okay, dy, dx. Dx jadi du over 2x. Macam tu. Okay. So now this can be cancelled. Kita pun dapatlah 1/2, 7 and 8, u to the power of half du. So integrate, we will get 1 over 2, u to the power of 3 over 2, over 3 over 2. So it becomes 2 over 3 lah. Boleh guys? Saya skip step tu. Faham tak?
Faham.
So substitute u equals to 7 and 8. So we will have This can be cancelled. We get 1 over 3 kan. So 8 to the power of 3 over 2 minus 7 to the power of 3 over 2. Okay, so settle. Ni baru part A. Kita nak solve part B pula. Solve part B. Part B, we have integration from 0 until 1 x square root of x squared plus 3. X squared plus 3 dx. So what should we do here? X cube pula. X cube. Ni, saya tersilap ni. X squared plus 3 dx. Ya, betul. We need to substitute again. So substitute lah lagi sekali. We let u equals to what? X squared plus 3 pula. So differentiate u, we get 2x dx. Therefore, dx equals to du over 2x. And then you have to change the limit. When x equals to 1, we have u equals to 1 squared plus 3, so we will get 4. And then when x equals to 0, we have u equals to 0 squared plus 3 equals to 3. Segitu. So next, integration. 0 becomes 3, 1 becomes 4. X maintains square root of u dx. Dx here becomes du over 2x. So du over 2x. So of course we can cancel this. So we will get 1 over 2, 3 and 4 u to the power of half du. So integrate, we will get u to the power of 3 over 2 over 3 over 2. So it becomes 2 over 3. Okay, so substitute 3 and 4. So again, this one can be cancelled. So we have 1 over 3, u, okay, 4 to the power of 3 over 2 minus 3 to the power of 3 over 2. Okay, so kita combine lah. A plus ke minus tadi? Minus. Okay, so A minus B. Does A minus B equals to 1 over ni salin balik lah. Copy. Check. Okay. 1 over 3 ni minus B. Ni B. Minus. Tolak ni. Okay.
Lepas tu kena lagi integrate.
Tak payah lah integrate. Kenapa nak integrate sekali?
Oh, okay.
Rajin je nak integrate banyak kali. Tak payah. Yang ni you maintain je lah. Yang ni this one maintain. This one maintain. Yang ni you boleh kecilkan lagi ni. So dia jadi apa ni? Punca kuasa 4, 2 over
3.
2 kuasa 2 over 2 kan? So dia 8 kan? Okay, so final answer would be 1 over 3, 8 to the power of 3 over 2 minus 7 to the power of 3 over 2 minus 8 minus 3 to the power jadi plus kan? Saya kena petang-petang ni. Ni minus jadi plus kan? So plus 3 to the power of 3 over 2. Baik kau. Kalau keluar final exam boleh jawab kan?
Makan masa.
Mungkin.
Understand the steps?
Faham.
Yes.
Okay guys. So